friends also. Okay. So, in this subject, we are going to discuss about digital design. That means how digital circuits that can be designed using hardware description language. Okay, so the HDL that uh, is nothing but hardware description language. Okay, so as we are using a computer, so whatever design that we can do, if we can do it using certain language, okay, so that we can simulate it, and then after that we can go for actual implementation of that circuit that we can do with a hardware description language. Okay, and for this we are going to learn about two languages, that is the VHDL and Verilog. Okay. As you all know that this subject carries 100 marks theory, 25 marks your ICA, that means your term work and all that part, and then 50 marks oral POE is there. Okay, that is a practical oral examination. आता सध्या आपण या पॅन्डेमिक सिच्युएशन मध्ये प्रॅक्टिकली ऍक्च्युअल जरी नाही परफॉर्म करू शकलो तरी आपण तुम्ही सगळ्यांनी डेमो बघितलेले आहेत. ओके, सो यू नीड टू राईट प्रोग्राम फॉर दॅट, आणि त्याच्याप्रमाणे मग तुम्हाला म्हणजे ऍक्च्युअली जेव्हा तुम्ही इम्प्लिमेंट करता त्याप्रमाणे तुम्हाला वेवफॉर्म ऑब्झर्व करता येते. सो दॅट यू नीड टू डू. तर आता आपण या सेशन्स मध्ये म्हणजे आपल्याला जे काही ऑलरेडी झालेलं आहे त्याची रिव्हिजन करणार आहे, आणि त्याचबरोबर त्याच्यामध्ये आपल्याला काय काही डाऊट्स असतील तुम्हाला तर ते पण आपण क्लिअर करणार आहोत. सो दिस माय फर्स्ट क्वेश्चन वॉज दॅट व्हॉट इज द difference between analog and digital? That means what is actually, first tell me what is analog signal and what is digital signal. Yes, what is mean the analog? Amruta. Mayur.
Analog signal has a continuous signal and digital signal has a discrete signal.
Okay, analog signal is a continuous signal. Yes, okay, so that means it is continuous with respect to time. And digital signal, that is a discretized signal. Okay, so it has two logic levels. Digital signal that has two logic levels. One is the logic 1 and logic 0. Okay, so here, what is advantage of using digital signal? Why we go for digital signal? As you know that all the parameters that are available analog in nature, or that are every signal is analog in nature, but we discretize it and we make it into digital and then we process it. ओके, हे आपला जो काही कुठलाही सिग्नल असेल आपण आधी त्याला काय करतो, डिजिटल फॉर्म मध्ये कन्वर्ट करतो, आणि त्याच्यानंतर मग त्याच्यावरती ज्या काही आपल्याला जे काही आपल्याला प्रोसेसिंग करायचं आहे ते आपण नंतर करतो. ओके, पण फर्स्ट ऑफ ऑल आपण काय करतो की प्रत्येक सिग्नल आहे तो काय अॅनालॉग टू डिजिटल मध्ये कन्वर्ट करतो. सो व्हॉट इज बेनिफिट ऑफ कन्वर्टिंग दॅट सिग्नल इनटू डिजिटल? असतो ना काही ऍडव्हान्टेज आहे ना, त्याशिवाय आपण करत नाही. काय आहे ऍडव्हान्टेज?
less noise and distortion.
Yes, it is a less noise and distortion. And another benefit, low power. Okay, it requires low power, and that is one of the advantage of using digital signal. Okay, so now we have different digital circuits. So we are going to see how to write HDL code for that, and then how to simulate that. Okay, so um, our first unit, that is a introduction to VHDL. So our first unit is an introduction to EDA tool and VHDL programming. So what is mean by EDA? Yes, what is mean by EDA? It is electronic design automation. Okay, so all the circuits that uh, electronic circuits that you can design using certain automation tools. Okay, so here we are going to discuss about VHDL programming. Okay, so it is a one of the electronic design automation tool, so that you can design certain uh, circuits on your machine. Okay, so तुमचा लॅपटॉप असू देत किंवा तुमचा पीसी असू देत, त्याच्यावरती तुम्ही डिझाईन करू शकता आणि त्याचं सिम्युलेशन करून तुम्ही व्हेरीफाय करू शकता वॉट एव्हर यू हॅव डिझाईन, whether it is correct or not. Okay, and then you can go for actual implementation. That means actually you have used multi-sim software. Okay, so in that you must have designed analog circuits and then simulated it. Okay, जिथे तुम्हाला पॉसिबल असतं की जर मी कुठलाही कंपोनंट चेंज केला तर त्याचा इफेक्ट काय होणार आहे सर्किट वरती आणि मग मला आउटपुट काय मिळेल हे तुम्ही बघू शकता. ओके, similarly in this VHDL programming, whatever the circuit that you are going to design, you can verify first it on your machine, okay, using waveforms, and after that you can go for actual implementation. Because as when you are going for a very small scale integrated circuit, okay, that is the VLSI circuits, so in that you can't go directly for the implementation. So there you need to check for the specifications, what will be the results that you are going to get, and then after that you can uh, actually implement that circuit there. Okay, so for that we require certain programming language, and VHDL is one of the programming language. Okay, Verilog is the another programming language, but mostly in academics this VHDL programming language that is. Okay, so in this unit, we are going to discuss about this VHDL, then what is the design flow in this VHDL programming, then what are the different EDA tools that also we will see. Then library declaration part, entity architecture declaration part, all that part, uh, which is related with the VHDL, then what different data types, operators, and all basic things that we are going to discuss in this unit. Okay, so as I have already shared study material of this subject, whatever is this PPTs, all books that I have already shared, PDF copies of all books that I have shared with you all in a study material sheet. Okay, one more thing I would like to tell you that I have shared lab manual of DDH. ओके, तुमची जी काही स्टडी मटेरियलची शीट आहे त्याच्यामध्ये मी लॅब मॅन्युअल शेअर केलेलं आहे. तर तुम्हाला प्रत्येक एक्सपेरिमेंटसाठी म्हणजे फर्स्ट एक्सपेरिमेंट नाहीये तो, पहिला पार्ट जो आहे तो इंट्रोडक्शन टू VHDL असा आहे. तर त्याच्यानंतरचे जे एक्सपेरिमेंट्स आहेत 10 एक्सपेरिमेंट, त्या प्रत्येक एक्सपेरिमेंटसाठी तुम्हाला 1 पेज रिपोर्ट लिहायचा आहे. ऑलरेडी आपण हे सगळे इम्प्लिमेंट केलेले आहेत, म्हणजे मी आपण त्याचा तुम्ही सगळ्यांनी त्याचा डेमो बघितलेला आहे. तर त्या प्रत्येक एक्सपेरिमेंटसाठी तुम्हाला 1 पेज रिपोर्ट लिहायचा आहे, की ज्याच्यामध्ये तुम्ही title of the experiment, then aim, and then here actually uh, we are not having any calculations or as such observations, okay, that we are not having, but you need to write a VHDL code, or if it is a Verilog programming, then you need to write Verilog code, and after that you need to draw waveforms, okay, for that. So considering certain inputs, like that means you need to write a VHDL test bench code also. So you can write draw waveforms for that particular input stimulus. So that you need to write, and then that will be your 1 page report for each of the experiment. So that you need to complete. Okay. So here, the book for this first unit, that this is the best book, that is by Pedroni, Circuit Design and Simulation with VHDL. So you can refer this book. Then also Brown and Barancik, that is also one of the book for VHDL programming. And then Roth, that is also there. Okay. या सगळ्या बुक्सचे मी PDF स्टडी मटेरियल शीट मध्ये शेअर केलेले आहेत, तर तुम्ही त्या रेफर करा. त्याचबरोबर PPTs पण शेअर केलेल्या आहेत प्रत्येक पॉइंटच्या, तर त्या पण रेफर करा. शिवाय आधी झालेले जे लेक्चर्स आहेत, जर तुम्हाला कुठेही डाऊट असेल तर तुम्ही आधीचे जे लेक्चर्स आहेत त्याचे व्हिडिओ शेअर केलेले आहेत त्या शीटमध्ये, यू कॅन व्ह्यू दॅट. आणि त्याच्यातून जर तुम्हाला काही डाऊट असेल तर तुम्ही कधीही विचारू शकता. ओके, सो दिस इज अबाउट द सिलेबस ऑफ फर्स्ट युनिट, दॅट इज इंट्रोडक्शन टू EDA टूल अँड VHDL प्रोग्रामिंग. Okay, so I'll skip this part and I'll just go to this electronic design automation. Okay, that is a EDA. So basically this is nothing but computer aided design. Okay, म्हणजे तुम्ही जे काही डिझाईन करणार आहे, that for that if you are using computers and then you are doing that design, then it is a also you are doing simulation on the computer, then we call it as a computer aided design. So that is a ECAD. So you need to use this so that that will make your design easier. Okay. Now this EDA design tools that have gone from transistors, then to the gate level, and then register transfer level, that is RTL design, and then after that graphic design. Okay, so that is a GDS. So all these are the levels for this computer aided design. Now, here for this computer aided design, we are going to first of all use one of the hardware description language, that is a VHDL. Now, this VHDL it has the long form, that is a basic, that is a VHSIC hardware description language. Now, this VHSIC, that means very high speed integrated circuit hardware description language. Okay. So this language is developed for the design of integrated circuit, okay, and that also very high speed integrated circuit. American Defense Department that has developed this VH language in 1980s. And after that, IEEE that has standardized VHDL, and if in its manual, that is the IEEE VHDL language reference manual in 1987. And after that, it got the standard, that is the 1164. So that is the standard of this VHDL language. Okay, so now this is about the why actually this VHDL language was developed. Okay, because one thing is that VHDL language that is used for digital system. Okay, now as we are using large circuit, so this digital system which is present in any of the uh, equipment or any circuit, the complexity of that going on increasing. And so if you are designing any circuit with just a simple gates, that was very easy. But as number of resistors, number of flip flops that are going on increasing, and that made design of this system very difficult. And that is why there was certain need which will reduce the complexity while designing that. Okay, so as breadboard was not uh, feasible for the complex circuits. So whenever the number of chips or number of components that were increasing on the board, so we need to simulate that circuit before going for the hardware, and that is why this there was motivation for developing VHDL language. Now it is not just checking the logic level, but it is also checking timing analysis. Okay, that means whenever you are applying certain signal, so what will be the timing analysis of that signal? That is also verified using this VHDL language. Okay, so that in that way it is a very important, and that made life of digital designers uh, ease at ease. Okay, so this is the use of VHDL language, but I'll skip this slide as we know that to make a complex circuit design easier, we are using VHDL. Okay. So now let us go for the basic features of VHDL. So the first basic feature of VHDL is that concurrency. Now can anybody tell me what is mean by concurrency? Satyajit?
Yes, madam.
Yes, what is mean by concurrency?
माहिती नाही मॅडम.
Okay. So what do you know about VHDL? You have completed diploma, ना? तुमचा डिप्लोमा
हा
झालाय
येस
ना?
मॅडम.
Okay, so
हा
you must have studied this language in diploma also.
डीप मध्ये नव्हतं मॅडम एवढं आम्हाला व्हीएचडीएल.
ओके ओके, मग किती होतं, काय होतं त्याच्यामध्ये, तेवढं तरी सांगू शकाल की नाही?
थोडं पार्ट होतं मॅडम, ऍडिशन सबट्रॅक्शनचे वगैरे प्रोग्राम होते.
म्हणजे मग ते करताना तुम्हाला कंकरन्सी म्हणजे कंकरंट स्टेटमेंट्स म्हणजे काय माहिती असेल ना, सांगितलं असेल की नाही, तुम्ही स्टडी केलं असेल.
शब्द ऐकला मॅडम, पण यांचं नेमकं मिनिंग माहिती.
ओके, बघा आता आता बघावं लागेल नेमकं मिनिंग काय आहे. आदित्य? आदित्य? Okay, so what is meaning of concurrency? अभिषेक? अभिषेक?
हा मॅम.
हा, कंकरन्सीचं मिनिंग काय?
मॅम नाही माहित. कॉन्करन्सी म्हणा आताच ऐकालो.
आत्ताच? बरं, आणखीन काय 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 आत्ताच ऐकायला लागलात?
एवढंच मॅम.
एवढंच का? याच्या आधी मी बोललेलं पण सगळंच मग तुमच्यासाठी नवीनच असेल.
नाही मॅडम, VHDL आम्हाला नव्हतं डिप्लोमाला ना जास्त.
जास्त नव्हतं पण थोडंफार तरी होत असणार. किती
हा
लेक्चर्स
प्रोग्राम
अटेंड
होती
केलेत
मॅडम.
आतापर्यंत? एक
हा
मिनिट, किती लेक्चर्स आतापर्यंत अटेंड केलेत तुम्ही?
मी मॅडम केलो एक बऱ्यापैकी म्हणजे
बऱ्यापैकी
केलो.
म्हणजे किती? आठवतात का किती केलेत ते?
निम्मे तरी केलेत मॅडम.
50% अटेंडन्स आहे तुमचं असं तुम्हाला म्हणायचं.
हम्म.
ओके, त्यातल्या पण म्हणजे मग मी जेवढे लेक्चर्स घेतले त्यातले 50% लेक्चर मध्ये एकदा तरी कंकरंट हा शब्द वापरलाय. दिस इज नॉट द वे टू टॉक. माहिती नाही तर माहिती करून घ्यायला पाहिजे. अजय,
Yes, ma'am.
what is mean by concurrent?
Yes, ma'am.
What is meaning of concurrency? Concurrency means you can stimulate certain programs simultaneously. Okay, so suppose you are using certain statements, okay, different statements. So if they are not dependent on each other, then they can be stimulated simultaneously at a, that means at one clock cycle. So that is called as a concurrency. Okay, so this is the basic feature of VHDL, that it is a concurrent language. Then another feature of VHDL is that it supports sequential statements. Though that means though it is a concurrent language, but still it supports sequential statements. That means the statements which are executed one by one. Okay. So sometimes we have assignments in such a way that result of first statement is used in the another statement. So that time we need to simulate that statements in a sequential manner. So this VHDL language that supports sequential statements also. Then it supports for test and simulation. So that means whatever are the different tests or simulation, for that also it supports. Okay. Then one of the important feature of VHDL is that it is a strongly typed language. Okay. In a VHDL, we have different data types, and it is needed in a VHDL programming that all whenever we are assigning certain data type for any of the identifier, we need that should be supported by that identifier, and then the same should be assigned to the output also. Okay? So that means we have to use correct data type in a VHDL. Otherwise, it will give error, and that design will not be correct. Okay. So for that purpose, we need to use a proper data type, and or we can say in another words that it should be a correct data type that is needed whenever we are doing VHDL program. Okay. Then it supports hierarchies. Then it supports vendor defined libraries. So there are certain libraries which are inbuilt in a VHDL programming, but at the same time, user defined libraries are also supported by VHDL. So that is the very good feature of VHDL programming. Now, what is mean by libraries? As we are using VHDL programming, we need to add certain functions for the that program. Okay, so VHDL has certain basic programs that are inbuilt whenever we are calling certain library. Okay, but at the same time, that if suppose we have certain design, and if we are want to add that functions in the program, so that also is possible in a VHDL. Okay, then it supports multi-valued logic. That is another feature of VHDL. So there are different levels of representation and abstraction whenever we are representing a digital system. Okay? So that means suppose we have certain digital system, then we can represent that system in a using Boolean expression. Okay, so that means what will be the Boolean expression for that system that we can express in certain equation, and then we can represent that system. Okay, so that type of modeling that is called as a behavioral modeling, or we can have a structural modeling. Okay, that means which component that we are going to use for that circuitry or for that system, and then what will be the different interconnections between these components. By specifying that, we can represent that. So that is the another way of representing a digital system, and then by using that we can implement that circuit. Okay, by we can implement physically that system. कुठलंही साधं अँड गेट जरी तुम्ही घेतलं तर अँड गेट म्हणजे काय आहे ए डॉट बी. ओके, or a ANDed with b. So that means suppose you have a expression that output is equal to a dot b or a and b. So that means that it is a AND gate. So that is a very simple uh, way of representing that AND gate. Okay? Or this in the same way you can have components used in that, and then you can, that means different gates that you can use, and then you can represent or a single represent that system. Okay? So here you can see in this example it is a OR gate, that is a A plus B. Okay? Now the same can be represented with the component also. So that will be structural modeling of that circuitry. So we can have a behavioral modeling or structural modeling, and then using any one of that we can represent or implement that system physically. Now system may be just standalone, that is a behavioral modeling, using behavioral modeling, or it may use a structural modeling, or it may combination of both. काही इक्वेशन्स जे आहेत ती आपण बिहेव्हिअरल मॉडेलिंगनी म्हणजे बुलियन एक्सप्रेशन्स यूज करून एक्सप्रेस करू शकतो किंवा रिप्रेझेंट करू शकतो, आणि नंतर त्यानंतरचं जे आउटपुट आहे त्याच्यासाठी आपण स्ट्रक्चरल मॉडेलिंग यूज करू शकतो. सो वी कॅन इम्प्लिमेंट in both the way, that is just using behavioral modeling or structural modeling, or using combination of both. So because of this, what happens, this complex system, whatever may be the complex system, that becomes manageable. So that is the different levels of representation and abstraction in a VHDL. So now here, whenever we are going for the design any digital system using VHDL, that time we have to go with certain design flow. Okay, and here this diagram that shows VHDL design flow. So there are basically two things. That is, one is the synthesis and another one that is the simulation. Now, whenever you are going for design, first of all, you will get certain specifications. कुठलंही डिझाईन तुम्हाला करायचं असू देत तर त्यासाठी तुम्हाला पहिल्यांदा काय लागतील तर स्पेसिफिकेशन. म्हणजेच काय काय डिझाईन करायचं आहे आणि मला आउटपुट काय पाहिजे हे पहिल्यांदा फिक्स पाहिजे, त्याच्यानंतरच डिझाईन करता येईल. म्हणजे बरोबर आहे ना, की आपल्याला माहितीच नसेल मला काय रिझल्ट पाहिजे तर आपल्याला डिझाईन प्रॉपर करता येणार नाही. त्यामुळे आपल्याकडे स्पेसिफिकेशन्स आधी अवेलेबल पाहिजेत. सो द फर्स्ट थिंग whenever you are going for any of the design, then you will require specifications. Then after that, you need to write a VHDL code for that, uh, using that specification. Okay, and after that, you need to generate. You need to simulate that VHDL code. Okay, so for that, first of all, what we do, we are using or we are generating RTL functional netlist. Okay, so whatever are the different nets that we are generating first, and then after that we are doing RTL functional simulation. Okay, so that is the first step that we do. After that, we are doing analysis and synthesis. So after that we are generating a post synthesis functional netlist, and then post synthesis functional simulation that is done. Okay, so what we are doing here, in the first step, whenever we are using specifications to write a VHDL code, after that we are first of all generating a RTL, that is a register tra transistor level netlist, and then after that we are doing a simulation. Okay, then after that we are doing analysis and synthesis. Okay, that is the post synthesis functional netlist is generated, and then functional simulation is done. Okay, so once this we do this simulation, after that we are placing and routing the components that are present in that code. Okay, हे सगळं केल्यानंतर जे तुम्ही आतापर्यंत बघितलं पण असेल, जेव्हा जेव्हा आपण सिम्युलेट करतो, आपण आरटीएल स्कीमॅटिक बघतो. ओके, so what we get in that RTL schematic, we are looking for the different components that are present in that schematic, and at the same time different connections. Okay, so once we get that connections, okay, after synthesis also, so we are placing and routing that components in such a way that it will fit in a small space, and it will reduce delays and so many parameters that are related with this design. So that we are doing, and then after that we are generating a post fitting timing netlist, and post fitting timing simulation is also done. Okay, then after that programming file is generated, and then that programming file is downloaded on physical device like a FPGA or CPLD, and then after that we get actual IC. हे तुमची आयसी जी काही तयार करण्याची प्रोसेस आहे ती कुठने सुरू होते, तर तुमच्याकडे काही स्पेसिफिकेशन्स असतील, त्यानंतर तुम्हाला VHDL कोड लिहावा लागेल. पहिल्यांदा तो कोड लिहिल्यानंतर डायरेक्टली आपण तो कोड डिव्हाइस मध्ये इम्प्लिमेंट नाही करू शकत किंवा डाउनलोड नाही करू शकत, तर त्याच्यासाठी आधी तुम्हाला तो सिम्युलेट करून बघायला लागेल. पण सिम्युलेट करण्याच्या सुद्धा परत वेगळ्या वेगळ्या स्टेप्स आहेत. हे पहिल्यांदा तुम्हाला जर VHDL कोड लिहिल्यानंतर आधी तो बरोबर आहे की नाही बघायला लागेल. त्यासाठी तुम्हाला नेटलिस्ट जनरेट करावी लागेल, आणि मग सिम्युलेशन करावं लागेल. नंतर परत तुम्हाला पोस्ट सिंथेसिस करायला लागेल. ओके, so that means you need to analyze that depending on the timing diagrams, and then after that you need to generate a post synthesis netlist. Then after that you need to do a routing, sorry, and then after that again post fitting timing netlist is generated, and then you get a programming file which is downloaded on a physical device. Okay, पण आता आपण जेव्हा बघतो तेव्हा आपण इथपर्यंतच करतोय की आपण काय करतोय की VHDL कोड लिहितो आणि त्याचं सिम्युलेशन करतो. ओके, सो वी आर डुईंग दिस स्टेप टिल दिस मच ओनली. ओके, दॅट इज RTL functional simulation. Now there are different EDA tools that are available in the market. So from Altera, that is a Portus 2, which is used for the synthesis as well as graphical simulation. Then we have Xilinx ISC, that is a XST for synthesis, and ISC simulator for simulation. Okay, so you must have seen that I'm using Xilinx ISC simulator. So that means I can do just a simulation here. So that we are using in our college also. Now after that there is a mentor graphics, that is a one more uh, EDA tool which is there for precision RTL and Leonardo spectrum, which is used for the synthesis, and then model sim, that is for simulation. Okay, so this model sim that is also used in academic for simulation purpose. So you may also use this as I said earlier, की तुम्ही पण हे डाउनलोड करू शकता आणि तुम्ही यूज करू शकता. So that is easier for using. Okay, after that there is a one more EDA tool, that is a synopsis or simplicity, uh, which is design compiler ultra and simplify pro premier. This is for synthesis and VCS for simulation. Okay, so these are the Altera, Xilinx, then Mentor Graphics, Synopsys, Cadence, Aldec. These are the different vendors, and they have given uh, various tools for simulation as well as synthesis. Okay, so we are using in our college we are using Xilinx ISC EDA tool for VLSI design. Now let us actually discuss with what is there in a VHDL. Okay. Now there are different units in a VHDL program. So whenever we are writing VHDL program, we need to use these units in that program. So the first unit, that is a library or package declaration. Then another unit, that is the entity, and third unit, that is the architecture. Okay. So whenever we are writing a VHDL code, these three units will be there in the VHDL code. Okay. So this is the when these three units are present in the code, we can say that that is the basic VHDL code. Okay. So the first part, that is the library declaration or package declaration part, then entity declaration and architecture declaration. Okay. So these three units will be there in a VHDL program, in each and every VHDL program. Now, what is there in the library declaration part? The library declaration that will have a package declaration. Okay. So, what package that we are going to use, that has to be declared in the program. Okay. Now, what is library declaration actually? Whatever are the different functions that we are going to use in that program, VHDL program, we have to first of all declare that. Okay, or we add that in that program. Okay, so for that we need to declare library, and then what different functions that are available in the package, so we need to add that package. Now this package had functions, then procedures, then declaration part which is related with components, signals, or certain constants, types, subtypes, all that will be there. Okay. Now if these packages that are inbuilt packages or that are readily available packages, then they will have certain functions related with that package. But as I earlier said that VHDL supports vendor defined packages also. जरी तुम्ही काही डिझाईन केलं असेल तर तुमचं पॅकेज पण त्याच्यामध्ये ऍड करता येईल. So that we can add in the library declaration part. Then this second part, that is the entity declaration part, where we are declaring input ports as well as output ports. That means whatever will be the input pins available for that IC and what will be the output pins available for that IC, that is declared in this entity part. And now how in the architecture part, how this will behave, all the inputs and will behave to get the output, that is declared in the architecture. म्हणजे पहिल्या पार्ट मध्ये काय आहे की आपण जे कुठले फंक्शन्स यूज करणार आहेत ते लायब्ररी डिक्लेरेशन पार्ट मध्ये आपण डिफाइन करतो. एनटीटी मध्ये काय आहे तर एनटीटी मध्ये जे तुमचे पिन्स अवेलेबल आहेत, इनपुट पिन्स किंवा आउटपुट पिन्स, त्या सगळ्या आपण एंटिटी मध्ये डिक्लेअर करतो आणि त्याच्यानंतर जे इनपुट्स अवेलेबल आहेत ते कसे बिहेव म्हणजे त्या प्रमाणात म्हणजे ते कसे असणार आहेत की ज्या प्रमाणात आपल्याला आउटपुट मिळणार आहे, डिझायर्ड आउटपुट मिळणार आहे, ते आपण आर्किटेक्चर मध्ये डिफाईन करतो. सो ऑल दिस कंबाइनली that gives us a basic VHDL code. Now let us see how to declare libraries or packages in the VHDL code. Now what is mean by libraries? As I said, the libraries that provides set of packages, then components, functions. Now why we are using these libraries? Because they are simplifying our task of designing hardware. मला जर फक्त अँड गेट डिझाईन करायचंय तर मला ते प्रत्येक वेळेला डिझाईन करायची गरज नाहीये. जस्ट इफ आय add a IEEE library, then automatically all these basic components, basic logic gets that will get added. त्यासाठी मला प्रत्येक वेळेला ते डिझाईन नाही करायला लागणार आहे. सो दॅट इज अ simplicity of that it is design. Okay, then packages that provides a collection of related data types and subprograms. So whenever we are declaring library, syntax for this library, then library name. Okay, so whatever is the library that we are going to add in that program, so that we need to write here. Okay, so this library is a keyword and library name that is a user defined. म्हणजे मला जी कुठली लायब्ररी ऍड करायची आहे त्याच्याप्रमाणे मला इथे स्पेसिफाय करावं लागेल. ओके, then there will be, after that we need to add package. So for that use, then whatever is the library name that we need to specify, then dot, then library package name, and then dot all semicolon. Okay, now dot all means all the functions which are available in that package that will get added. Okay, so we can use all the functions or all the data types that are available in that package that we can use in this program. Okay, म्हणजे आपण जेव्हा जेव्हा हे डिक्लेरेशन करतोय ते मी जेव्हा कुठली पण लायब्ररी यूज करणार तर त्या लायब्ररीच्या त्या पॅकेजमध्ये जेवढे कुठले फंक्शन्स अवेलेबल असतील ते मी यूज करू शकेन. ओके, विदाउट एनी एरर. ओके, so here mostly we are using IEEE library. So IEEE here, how we can declare that part? Library, then IEEE, after that semicolon. Now each and every statement in the VHDL that should be ended with semicolon. Okay? Otherwise it will give a syntax error. So प्रत्येक स्टेटमेंट जे आहे त्याच्या एंडला तुम्हाला सेमिकोलॉन द्यायलाच पाहिजे, अदरवाइज तुम्हाला एरर मिळणार आहे. ओके, सो लायब्ररी, that's the keyword. So whenever we are using any keyword in a VHDL programming, that is available in the blue color. तुम्ही कधी पण तुमचा VHDL चा प्रोग्राम जर बघितला तर जे कीवर्ड्स आहेत ते तुम्हाला ब्लू कलर मध्ये दिसतील, डेटा टाइप्स आहेत ते पिंक कलर मध्ये दिसतील आणि जे युजर डिफाइंड असेल ते ब्लॅक कलर मध्ये आहे. त्यामुळे जेव्हा तुम्ही लायब्ररी टाइप कराल तुमच्या VHDL कोड मध्ये तर तो ब्लू कलर मध्ये तुम्हाला तिथे दिसेल. आणि त्यानंतर जे पॅकेज असणार आहे ते मात्र ब्लॅक कलर मध्ये असणार आहे. सो दॅट इज देअर. ओके, देन आफ्टर दॅट we are using adding a package to that. So use, then we are adding a package std underscore logic underscore 1164. That is the standard package which is related with the standard logic. Okay, so here we have IEEE dot std underscore logic underscore 1164 dot all. That means what we are doing, we are adding all the packages, all the functions of this package to this program. So this is the library declaration part. Now whenever you are writing any program, you need to first declare this part. But whenever we are using Xilinx that time, when automatically you must have seen that automatically skeleton of that program that we get. ओके, ज्याच्यामध्ये लायब्ररी डिक्लेरेशनचा पार्ट असतो, एंटिटी डिक्लेरेशनचा पार्ट पण असतो. जर आपण आधीच म्हणजे त्या टेबल्यूर फॉर्म मध्ये आपण जर पोर्ट्स डिक्लेअर केले असतील तर तिथून तुम्हाला डायरेक्टली एंटिटी मिळते. फक्त जर डेटा टाईप चेंज करायचं असेल तर चेंज करावा लागतो. अदरवाईज जे आहे ते फक्त आपल्याला लिहायचं कुठे असतं तर आर्किटेक्चर मध्ये असतं. सो दिस IEEE लायब्ररी आणि IEEE.std_logic_1164 हे पॅकेज ऑटोमॅटिकली ऍड होतं कुठलाही तुम्ही जेव्हा प्रोग्राम लिहित असाल तेव्हा. कारण आपण लॉजिक डिजिटल लॉजिक तर यूज करत असतो, त्यामुळे हे जे पॅकेज आहे ते त्याच्यामध्ये ऍड होत राहतं त्या प्रोग्राम मध्ये. सो but if you want to use any other package, then you need to type that in that program. Okay, so that means suppose you want a numeric data type package, so that you need to add there, or if you want a package related with the sign numbers, so or arithmetic operations you want to perform, so package that you need to add in the program. Now after that, we have architecture, entity declaration part, then architecture and configuration. Okay. So in an entity declaration, that means it is the part where we are specifying what will be the input pins and what will be the output pins for that system. Okay. Now, and in the architecture part, there will be interfacing between the components that are used in that system. So that will be present in the architecture. Now, for single entity, there can be number of architectures that may present. So let us see what is meant by entity. Entity, it is a specifications of the design's external interface. So in other words, as I said, we can say that these are the, here we specify the input pins as well as output pins of that particular IC. So in our entity declaration, that specifies the name of the entity, then set of generic declaration specifying instance specific parameters, then set of port declaration defining the inputs as well as outputs of the hardware design. At the same time, in an entity declaration part, there may be generic declarations and port declarations that may be optional. Okay. So if we are using components, that time that part may be optional. So now let us see how to declare library entity. Sorry, entity declaration. The syntax for that is, first there will be keyword, that is a entity. So here in the bold letters, whatever is there, that is a keyword. Okay. Then after that, there will be entity name. So this is a user specified name which will be available for that particular entity. Okay, and then there will be a keyword is. Okay, now remember that after is there is no semicolon. Okay? And after that there will be generic declaration. So that means those declarations which will be available for all the functions that could be there. Then port declaration, then entity declarative part, certain constant types, signals that are there, then that could be declared. And then the keyword, that is the end, and entity name. Okay. Now here this entity name, that is optional. That means actually here whatever is written in the square bracket, that is the optional part, and whatever is the present in a curly bracket, so that is a choice of none. Okay, so that means mostly that part is not available. Okay, so this is the syntax for entity declaration part. So what is entity declaration? Uh, Entity declaration, that means actually it is an external view of component. Okay, but though this is saying external view, but how these components or that is going to be implemented, that is not explained in the entity. ते फक्त एंटिटी मध्ये काय दिसेल तुम्हाला की आउटपुटला काय असणार आहे, इनपुटला काय असेल हे कळेल, पण ते बिहेव कसं करणार आहे हे काही कळत नाही आहे एंटिटी मधनं. ओके, सो दॅट इज द एंटिटी डिक्लेरेशन पार्ट. Then after that, as we said that in a entity declaration part, we have generic declaration. So generic declarations are the that declares constants that can be used to control the structure or behavior of the entity. So syntax for this generic is generic, then in the bracket constant name, so that is a name given to that constant, and then after that colon, then type. Okay, so whatever is the type of that constant, and then there may be initial value. Okay, so as it is available in the square bracket, so it is not compulsory to specify that initial value. Okay, so this init value, that means the initial value for that constant. Okay, then there may be number of constants that are present, so that are separated with a semicolon, then end of the bracket, and then semicolon. Okay, so this is the way to declare generic declarations. Now the port declarations that specifies the input as well as output ports of the entity. So for port declaration, the syntax is port in the bracket, round bracket, port name. Okay, so this is a user defined name, then colon mode of that port. Okay, so that means it is whether it is a input port or output port or in output, so that is specified, then type of that port, and sometimes it may have the initial value. The number of ports are separated with semicolons and they are uh, declared in the same manner. So that means port name will be there, then colon, then mode of that port, then type of that port, and if suppose initial value we want to mention, then that will be there. So whenever we are giving the name to this ports, so we can type this in any of the case. Okay, म्हणजे तुमचं केस कुठली पण असू शकते, upper case or lower case, that will not make difference. As I'm saying this in most of my lectures, that VHDL is a case insensitive, so you can type it in any of the case, upper case, lower case, काही असेल काही फरक पडत नाहीये. So here that means there is a one example that is given, that is if you have declared port name as a XYZ, then though you use X, capital Y, capital Z or all capitals, it will not make difference. It will considered as a XYZ only. तुम्ही कुठल्याही केसमध्ये लिहिलात काहीच फरक पडणार नाहीये, तो XYZ असंच कन्सिडर करेल. ओके, so that is the one of the feature of VHDL language, that it is not case sensitive. And as I said that mode that will indicate whether it is a input port or output port, that means actually it will specify the direction of that port signal. Then type, that means whatever is the data type of the port, and initial init value, that means it is the initial value for that particular port. Okay. So whenever we are declaring a port, we have certain choices for the port name. So we have first thing is that it consists of letters, digits and underscores. Okay, so no any other special character is used in a port name. Okay, it has to start with a letter only. Okay, and then it may be followed by digits or underscore, but it has to start with a letter. And as I said that it is a case insensitive, that means तुम्ही कुठल्याही केस मध्ये लिहिलं काही फरक पडणार नाही. Then mode of that port, for that we need to select port direction. So there are different ports direction. So that is the in port, that means in, that means input port, out, that means output port, and in out port, that means bidirectional port, then buffer, that means buffered output port. So these are the different output ports, different ports that are directions that are available in the VHDL. Now here a buffer is an output that can be read by the architecture of the entity. Okay, so here though buffer that means it can be also used as the input port for that particular architecture. म्हणजे ज्यावेळेस तुम्हाला एखादा आउटपुट आहे आणि ते तुम्हाला ॲज अ इनपुट म्हणून पण परत वापरायचं असेल तर त्यावेळेस तुम्हाला ते ॲज अ बफर म्हणून यूज करता येतं. जेव्हा ऍक्च्युली असं आहे की तुमचं आउटपुट आहे एखादं आणि तेच तुम्ही इनपुट म्हणून पण त्याच आर्किटेक्चर पुरतं वापरणार आहे, म्हणजे त्याच्यावरती प्रोसेसिंग करणार आहात, तर तिथे तुम्ही बफर वापरू शकता. कारण तुम्ही फक्त आउटपुट म्हणून म्हटलं तर ते तुम्हाला आउटपुट फक्त दाखवेल, ते ऍज अ इनपुट म्हणून नाही वापरता येईल. सो त्याच्यासाठी तुम्हाला ते बफर म्हणून यूज करावं लागेल. सो हियर IEEE standard, that is a 1164, which was defined in 1993, that defines a package which provides a set of data types that are used for logic synthesis. So there are certain data types that are useful for logic synthesis that are defined in this package. The external pins of a synthesizable design must use data types specified in this std underscore logic underscore 1164 package. IEEE recommends the use of following data types to represent signals in a synthesizable system. Okay, so there are different data types that are available in a VHDL. We are going to discuss that after this, but whenever we are going for the IEEE standard, that is the 1164, it is recommended that data types must be usually of the type std underscore logic, or if it is a bus, that means if we want to specify that input or output as a bus, then we can use the data type as a std underscore logic underscore vector whenever we are using a data type package that is a std underscore logic underscore 1164. But here we can use different data types also, even, but for that we need to add certain another packages to that library. So whenever we are declaring the entity, we need to first of all use a keyword, that is the entity. Then after that it is a will followed by entity name. So user has to specify this name, and then after that there will be a keyword, that is is. Okay. Then after that there is a port. This is keyword is used, and in the bracket all the port names followed by port direction and then port type. Okay, so that will be there. Each of this port will be separated with a semicolon. Okay. Last port name will not have semicolon, but then after that bracket will be completed, and outside that bracket there will be a semicolon. Then end keyword will be used, and then एंटिटी नेम. ओके, जे इथे नेम्स तुम्ही स्पेसिफाय केलं असेल तेच इथेच दिलं पाहिजे आणि देन सेमिकोलॉन. So this is the entity declaration syntax. Okay, so the simple example for this entity declaration is, suppose we want to declare an entity for AND gate. Now how many input pins are there for AND gate? Suppose we are going for 2 input AND gate. So how many inputs will be there for that AND gate? मग जर 2 इनपुटचं AND गेट असेल तर मला इनपुट पिन्स किती असतील? Kshitija?
2, ma'am.
Yes, there will be 2 inputs and output for AND
1.
gate? One
1.
output will be there. Okay. So that means, suppose I am saying that A is one of the input and B is another input. Okay. And C is the output. So how I am going to declare entity for this AND gate? Then entity, this keyword will be used, and after that a name for this entity. Okay. So here this name is given as a AND gate. So remember that this name has started with a letter. Okay. Now there is no any special character, that means underscore, that is the only special character is used, but that is not used here, or alpha number is also not used in this name. Okay. So just a simple name given, that is a AND gate, and then after that a keyword is used. Then after that we want to declare ports. So for that port keyword is used, and in the bracket all the port names that we need to specify. Okay. So the first port name, that is A colon. Okay. So that this separated with a colon. Then direction of this port, that is a input port. So in, and then type of this is a bit. Okay. So that means A will be bit type. Now mostly as I said earlier that we whenever we are using IEEE dot std underscore logic underscore 1164 package, that time it is good to use std underscore logic data type. Okay, so instead of using bit data type, it is good practice to use bit type of std underscore logic type of data. Okay, but here I have used this bit. Okay, so that is the another data type. Then B, that is the another port. So here after ending of this first port declaration, then second, that is a B, then colon in, and then bit. Okay, semicolon C colon. Now the direction of this port is the output port. So out. This is the keyword and then bit, that is the data type. Okay, end of the bracket and then semicolon, then after that end of this entity, then AND gate, that is the name given to this entity, so that will be there. So after that there is a semicolon. Okay. So remember that whenever we are declaring this port, all the ports, each of this port is a separated with semicolon. So you need to remember this, otherwise it will give error while simulating this program. So now there is a one more example for entity declaration. Now suppose we want to write a full adder VHDL code. Okay, so for that we need to write entity. Now how many input ports are there for full adder? फुल ॲडरला किती असतात इनपुट पोर्ट?
3 input, madam.
Okay, and output ports?
Two.
Yes. Okay. So whenever we are going for full adder, so it will have two inputs plus one carry. Okay, so that means there will be three input ports, that is a carry in A and B. These are the two bits, and then output ports. One is the sum and another one, that is a carry, output carry. So this will be the output port. So here you can see that entity for full adder is, and now what is done here, we can all the input ports that can be written as a separated with a cell कॉमा. ओके, म्हणजे इथे जे काही इनपुट पोर्ट्स तुमचे सगळे एकाच टाईपचे जर असतील तर तुम्ही ते कॉमानी सेपरेट करून एकदम लिहू शकता, आणि त्याच्यानंतर या सगळ्या पोर्ट्सचा जो काही तुमची डिरेक्शन असेल म्हणजे मोड असेल तो, आणि त्यानंतर त्याचा डेटा टाईप. ओके, म्हणजे आता इथे ए बी आणि सी हे ऑल हे काय आहेत, बिट टाईप आहेत, म्हणून मग एकाच टाईपचे आहेत, तर तुम्ही ए कॉमा बी कॉमा सी colon in and then bit. Okay, so in this way you can write it. Then after that sum comma cout, all these are the output ports, and then data type, that is a bit. So in this way you can write. Then after that end of this entity. Okay, so this is the another way to write a एंटिटी. जिथे जिथे तुमचे एकाच टाईपचे जर इनपुट पोर्ट्स असतील तर तुम्ही ते कॉमनली सेपरेट करून घेऊ शकता. म्हणजे इथल्या आधीच्या एंटिटी मध्ये आपण काय केलं, हे प्रत्येक वेळेला सेपरेट लिहिलं, पण आता जर तुम्ही तुमच्याकडे जर 4-5 इनपुट पोर्ट्स असतील आणि ते सगळेच एकाच टाईपचे असतील तर एवढं 5 लाईन्स करण्यापेक्षा एकाच लाईन मध्ये तुम्ही लिहू शकता. म्हणजे ए कॉमा बी कॉमा सी कॉमा डी कॉमा ई हे सगळे इनपुट पोर्ट्स आहेत, आणि जर ते एकाच टाईपचे आहेत तर तुम्ही एकदम स्पेसिफाय करू शकता in a single line. So that is the entity declaration part. So this is the example. Now let us move forward and let us see the third unit of the basic VHDL course, that is architecture. Now what is architecture? Architecture is a specification of the design's internal implementation. Okay? So in a entity we are having what will be outside view or external view of that implementation. But in a architecture, what will be there in an internal circuitry, that is specified. Okay. So if suppose we have a single entity, for that we can have multiple architecture. म्हणजे माझ्याकडे जर फक्त एकच एंटिटी जरी अवेलेबल असेल तर मी त्याच्यासाठी वेगवेगळे आर्किटेक्चर्स लिहू शकते. सो हियर फॉर एनी ऑफ द entity we can have multiple architectures. For example, we might wish to create several architectures for a particular entity, with each architecture optimized with respect to design goal. Now whenever we are going for any of the design, our goal may be that it should perform good. Okay, so performance level that should be high. Then area occupied by that circuitry, that should be less. Then power consumptions, that may be the another goal, that it should consume less power, or simulation should be easy. Okay, so that may be the another goal. So depending on that we can have a different architecture for that particular program or that particular entity. So here this is the syntax for architecture declaration. So architecture, this is the keyword, then architecture name, then again there will be a keyword, that is of, then entity name. So here we need to specify the name of the entity for which we are writing this architecture, and then is there. Okay. After that, there is a architecture declarative part is there. So that means suppose we want to declare certain signals which we are going to use in that particular architecture that we are declaring here. Okay, so this is the optional part. Then after that, there will be a keyword that is a begin, and then we use certain VHDL statements to assign output. Then after that, end of the architecture. So for that, we use end, keyword, and then architecture name followed by semicolon. So this is the syntax for architecture declaration. So suppose we want to declare architecture for AND gate. So we can specify it with the architecture, then synthesis one, that is the name given to this architecture, then of, then we are writing this architecture for AND gate. So entity name, that is the AND gate, and then is. Then after that, we don't have here any declarative architecture declarative part. So we can directly start with the architecture. So begin, this is the keyword that we are using. And then we have assignment statement for that particular output. Okay, so we are assigning here C is assigned as A and B. Okay, so this and is the keyword, okay, which will perform a logical AND operation. Okay. Now here, whatever are the different statements that we are writing in the architecture, that should be ended with a semicolon. Here, this less than or equal and equal to, this operator is used for the assignment operator. Okay, so whatever is the result of this operation, that will be assigned to this particular code. जेव्हा कधी हे स्टेटमेंट एक्झिक्यूट होईल त्यावेळेस या स्टेटमेंटचा जो काही रिझल्ट असेल तो या आउटपुटला असाइन होईल. अँड देन इन आर्किटेक्चर डिक्लेरेशन पार्ट देर विल बी एंड कीवर्ड अँड देन एंड ऑफ द architecture is done using end, keyword, and then name of the architecture, that is a synthesis one. So this is the architecture declaration part. So this is the another example for architecture declaration of full adder. Okay. So if you have any doubt up till this, you can ask. अभिषेक, काही डाऊट आहे का? Any doubt?
No, ma'am.
So what I'll do, I will stop sharing this, okay, and I'll share the Xilinx and So I'm using Xilinx Design Suite 14.7. So I'll present that one. So this is my Xilinx ISC window. Yeah. So here you can see there are different windows that are available here. So whenever you are opening this Xilinx, so that time you will get a small window which is showing tip of the day. Okay, if you, so that will keep every day whenever you are opening this Xilinx, so you will get a tip of the day. So that will help you to effectively use this Xilinx. Okay, so let us close this. And as we want to use a new project, so we are going for file here, option file, click on that, click on new project. Okay, give a name to this project. Okay, as I'm going to have a simple AND gate, so I'll give a name that is a AND gate. Okay, now here there will be a option to select a top level source type. Okay, so there are different options, that is a HDL, schematic, then EDIF, NGC or NGO, but we are using hardware description language, so use this source type as a HDL. Click on next. Okay. Then here you will find a new project wizard which is showing a project settings. So you need to select these settings. So property name, that is a value, that is a by default, that will be there. Then evaluation development board, that you can specify here, but I'll keep this as a non-specified. Then product category, that is a all, and here then you need to specify a family. Okay, so which FPGA board that you are going to use, that is specified using the family. So here you are going to select Spartan 3E. Then device name, so you can select any one of the device. So I have selected XC3S 500E. Then package, so these are the different packages. So I have selected VQ100. Then speed -5 and -4. So I have selected -4. Then as we have already selected top level source type as a HDL, so now here this option is disabled. Synthesis tool, that is a XST, VHDL or Verilog. Simulator, we have different simulators here, but out of that I have selected iSIM, VHDL or Verilog. Then preferred language, that is a VHDL. Here the another option is Verilog, but now we are doing VHDL programming, so we are going to have this option as a VHDL. Then properties specification in project file, that is store all values that we have selected. So after selecting all these settings, click on next. So here you will get project summary, click on finish. Okay, so here in this you will hierarchy, you will get this and get project, that is right click on that and click on new source. Okay, and now we are going to write a VHDL program, so click on VHDL model, give the name as to, now this name, that is the source name, so I'll select this as the AND gate as it is, add to project and click on next. Now here this Xilinx IC that gives us facility to declare all the ports in this new source wizard that where we are defining the module. Okay. So entity name by default it will take as a AND gate, okay, which we have given to this file or source name. So by default it will take it, but otherwise you can change this name. Architecture name by default it will take as a behavioral. If you want to change it, you can change. Okay. Now here we have to give the input as well as output. तुम्हाला जर इथं द्यायचे नसेल तुम्ही स्किप करू शकता हा पार्ट आणि तुम्ही पुढे प्रोग्राम मध्ये लिहू शकता, बट आय विल यूज इट हियर. तर माझ्याकडे इनपुट पोर्ट्स अँड गेट साठी काय असणार आहेत ए आणि बी. आता इथे आपण सिंगल बिट आहेत हे दोन्ही पोर्ट, त्यामुळे इथे बस हा ऑप्शन सिलेक्ट करणार नाहीये. ओके. आणि सी हा पोर्ट काय आहे माझा आउटपुट पोर्ट आहे, तर इथे क्लिक करून इथे आउटपुट करता येईल. अँड देन क्लिक ऑन नेक्स्ट. Okay, finish. So here you will get a skeleton for this program. So just you can see here IEEE library that will get added. Then entity, that is an end gate that has been also declared here. So here just type a statement in the architecture, that is a C is assigned to A and B. So this is just a program. आता एवढाच प्रोग्राम हा फक्त आपल्याला एंड गेट साठी द्यायला लागणार आहे. So save, then go to synthesize, check syntax. Okay, then check for the RTL schematic. Whenever we are going for this, it will generate a netlist. Okay, so here you can see that these are the this is the schematic for AND gate. Okay. Now we want to simulate this. So that means actually we need to give certain inputs to the input ports, and then depending on that input we will get the output. So here we have to write a test bench code for this program. So okay, so here we need to write a test bench code for this. So for this we have to click on the your file name. So click on and right click on that, and then after that click on VHDL test bench, give the name to this file. So I'll give this name as a AND gate underscore TB. Click on next. So here we have to associate this code with a particular source. Okay, so we are associating with AND gate. आपल्याकडे आता इथे एकच सोर्स असल्यामुळे वेगळं काही येणार नाहीये, पण इथे आपल्याला ते असोसिएट करावे लागतील. जर मोर दॅन वन सोर्सेस असतील तर दॅट पर्टिक्युलर सोर्सला तुम्हाला ते असाइन करायला लागेल. आता जेव्हा आपण टेस्ट बेंच लिहितो तेव्हा काय ऍक्च्युअली होतं की तुमचा जो काही कोड तुम्ही लिहिलाय त्याच्याशी तुम्ही असोसिएट करताय त्या VHDL कोडशी, तर तो जो कोड आहे तर त्याचा कंपोनंट याच्यामध्ये ऍड होतो. ओके, सो हिअर यू कॅन सी दॅट दिस AND gate is declared as a component in the architecture board. Now here, as we have seen that in a earlier slide, we have seen that in an entity, port declaration is also optional. इथे तुमचं इथे गरज नाहीये कारण आपण इथे कंपोनंटच फक्त घेतोय, तर पोर्ट डिक्लेरेशन पार्ट हा ऑप्शनल आहे. आणि मग आपण ते सगळे जे पोर्ट्स आहेत याचे आणि इथल्या या ज्या एंटिटीचे आहेत ते मॅप करू शकतो. ओके, सो हिअर you can see that this component that has been instantiated here, so which has the ports that is the A, B and C. Now after that, initial values for these ports that has been declared as a 0. We don't require clocks, so I will make it as a comment. Then after that, here this clock process that is also not needed, so clock process that is simulated. So after that, let us give different inputs here. So let us say first A is equal to. Now whenever you want to declare any value or assign any value to any of the port, so that time if it is a single bit value, so declare it in a single quote. If it is a multi-bit, that means if it is a bus, then we have to write it in a double quote. So let us say A is 0 and B is also 0. Then we are going to wait for 10 nanosecond. I will make this also 10 nanosecond. I have copied this code and I will paste it. Okay. So as I have 4 combinations, so I will use all these combinations here. So what I have done, I have first for 10 nanoseconds I have kept 00 inputs, then 10 01 and 11. म्हणजे मी सगळे जे काही कॉम्बिनेशन्स अवेलेबल आहेत ए आणि बी इनपुट साठीचे ते सगळे यूज केलेले आणि त्याच्यानंतर मी सिम्युलेट करणार आहे. आता प्रत्येक याच्यानंतर मी काय केलंय की 10 सेकंड साठी मी वेट करते. ओके, सो फॉर दॅट आय हॅव यूज दिस स्टेटमेंट दॅट इज अ वेट फॉर 10 नॅनोसेकंड. Okay, and then after that end of this architecture. Okay, so let us save this. Now I want to simulate this, so click on simulation at the view, then click on this test bench program file, expand this iSim simulator, check for the syntax. Okay, there is error. So what is the error in this code? Okay, I have forgotten to give a semicolon at this end. So that is why that error was there. Okay, now simulate this. So for this, click on simulate behavioral model. So here now we have zoomed in, and then after that we are going for this waveforms. Okay, so here you can see that whenever input is 0 0, output is also 0. When it is 1 0, output is 0. For 0 1 also it is 0. But whenever both the inputs goes 1, output is 1. So this is the simulation for AND gate. Okay. So is it clear to you all? आपण इथे काय केलं, लायब्ररी डिक्लेरेशन पार्ट, पण आपल्याला ते डायरेक्टली करायची गरज नाही लागली. ऑलरेडी आपण जेव्हा प्रोग्राम लिहितो तेव्हा आलं, पण आपल्याला इथे काय करायला लागलं, या प्रोग्राम्स मध्ये जे कुठले पोर्ट्स एंटिटी आहे ते आपल्याला डिक्लेअर करावे लागले, आणि त्याच्यानंतर आर्किटेक्चर मध्ये आपल्याला त्याचं इम्प्लिमेंट कसं करायचं ते डिक्लेअर करावं लागलं. ओके, सो दिस इज द VHDL code for simple AND gate, and here you can see that this is the basic model. Now after this we are going to see how we can write different VHDL code. But now you must have got idea about the basic units in the VHDL code, that is a library declaration part, then entity declaration part, and then architecture declaration. Okay, so is there any doubt about this? Pradeep? कुणाला काही डाऊट आहे का याच्यामध्ये? If there is no any doubt, then we will stop it here for today. Okay. कुणाला काही डाऊट आहे का? मी परत विचारते.
No, ma'am.
Okay, so we will stop here for today. In the next session again we will discuss about these basic things.
Ma'am, roll number 12.
Okay.